Hey kiddos, hope you're having a good day. You're probably watching this on Wednesday. As you can tell, I'm in the video making mood. And so, same festive outfit. You'll have to hop into a Google Meet to see what else I have on for Wednesday. So today we're moving on to the second type of sequences. So we did arithmetic the past 2 days. Today we're doing geometric sequences. So we're doing the exact same thing that we did for arithmetic. We're learning how to identify, we're learning how to find the nth term, we're learning how to write recursive and explicit formulas. So since you all already have the background information for what each of those things are and what those mean, these notes are going to be shorter than they were on Monday and Tuesday. And I am going to do them all in one video instead of breaking it down. So if you're someone that needs to do notes and then do practice and do notes and then do practice, please feel free to pause the video and go hop in and do the practice and come back once you finish that section. Or if you want to watch the video all the way through and you're taking good notes, and you'll be able to hop right in and answer the questions in the module. I'm going to go through notes, so like your first module will line up with the first thing that we do here, and so on and so forth. So the first thing we're going to do is geometric identifying. So a geometric sequence it's still a list of numbers that follow a rule. But geometric is the rule is always multiplication. The rule is always multiplication. So that is the main difference between arithmetic and geometric. Arithmetic is addition, geometric is multiplication. So for example, if we are given the sequence 12, 6, 3, and we're asked to find the common ratio. So arithmetic has the common difference. This is going to have the common ratio. The common ratio is the same thing, is essentially the same idea as the common difference. So it's going to be, you're going to see what you're multiplying by to get from term to term, or you can think about it as it equals A2 divided by A1, or it equals A3 divided by A2, and so on and so forth. So for this one, we're going to have 6 over 12, and that's going to give me 1/2. We're going to have 3 over 6, and that's going to give me 1/2. So because that is consistent, that means this is a geometric sequence. Or you can think about it, how do I get from 12 to 6? By multiplying by 1/2, 6 to 3 times 1/2. So initially you might look at this and think, oh, or dividing by 2. Well, remember, we're dealing with multiplication, not division. So you're going to have to put that dividing by 2 in terms of multiplication. Another example would be if I have 3, 12, 48, ... What am I multiplying by to get from 3 to 12? Well, I think most of us can say we're multiplying by 4. From 12 to 48, that's also going to be times 4. Or if you weren't too sure, you could do 12 divided by 3, which is going to give you 4. And then 48 divided by 12 is also going to give you 4. So your common ratio is 4. So that's how you're going to tell if it is a geometric sequence. It's checking for your common ratio. So next, we're moving on to finding the nth term. So the formula for doing this is going to be A1 times r to the n minus 1 power, where A1 is your first term, r is your ratio, and n is what you're trying to solve for. So this is going to equal A2. So if we are asked to find the 14th term, 14th term of 5, negative 10, 20, so on and so forth. So we could find our common ratio and then just do this a whole bunch of times until we get to 14 in the calculator. Or we can use this formula and simplify that for ourselves. So we want to find the 14th term. So the 14th term is going to equal our first term, so 5, times my ratio. Well, to get from 5 to negative 10, I'm going to multiply by negative 2. Negative 10 to 20, I'm also going to be multiplying by negative 2. Or negative 10 divided by 5 or 20 divided by negative 10 are both going to give you that negative 2. So we're going to use parentheses, negative 2. And then n is going to be my 14 minus 1. So then you're simply just going to plug all of this into your calculator exactly as you see it. Make sure you're putting your parentheses around your negative 2. And that's going to give you a to the 14th equals negative 40,960. Same thing here is if we're asked to find, we have the sequence 2, 6, 18, and we want to find the 26th term. So we're going to use our formula. So we want to find the 26th term. That's going to equal our first term times our ratio to the 26th minus 1. So 6 divided by 2 is going to give me 3. 18 divided by 6 is going to give me 3. So my common ratio is going to be 3. So then I'm just going to type this into my calculator. So 2 times 3 to the 26 minus 1 is 25. And as you can see, it gives me a really big number. I made this example up on the fly because I didn't like the one I had written down. You will not be getting numbers that are this big. But remember, e to the 12th, that's scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we get a gigantic number, which makes sense because if you multiply by 3 times 3 times 3 times 3 over and over and over again, you are going to get a really big number really fast. So there's that one. And then moving on to our last two, we're going to be writing recursive equations like we did with arithmetic. So we're going to have geometric and recursive. And the formula for that is to be in a recursive form. It's going to be a to the n equals r times a n minus 1. So remember, for recursive formulas, you have to know the term before it in order to use it. So this one's not as user-friendly as the explicit form, which we're going to do next. So for instance, if I have the sequence 96, negative 24, and 6. So whenever you're getting smaller, you're going to want to recognize that you're going to be multiplying by a fraction. So whenever you think you're dividing, you're really multiplying by a fraction. So I'm going to check my ratio, negative 24 over 96. That's going to simplify down to negative 1/4. And then 6 over negative 24 is also going to simplify down to negative 1/4. So my common ratio is negative 1/4. And now I'm ready to write my equation. So it's going to be a to the n equals my common ratio, so negative 1/4, times an minus 1, because I'm just writing an equation in order to be able to find things. So I don't know what I'm trying to find. I'm just writing a generic equation to do so. So essentially, all you have to do to write the recursive formula equation is just find your r, and then you're rewriting your an minus 1. So for instance, if I wanted to find the third term of this, it's going to be an equals negative 1/4 times a. I want to find the third term, so 3 minus 1. So a at the end is going to give me negative 1/4 times the second term, because 3 minus 1 is 2. So a at the end, negative 1/4 times my second term is negative 24. I'm going to plug that in my calculator, and I am going to get 6. So that means my equation works. So for another example, if I have 3, negative 18, and 108. I'm going to find my ratio. So I'm going to be multiplying by negative 6 here and multiplying by negative 6 here. So that means my common ratio is negative 6. So my equation is going to be AN equals, put that negative 6 in parentheses, and then A to the N minus 1. Not too bad. And then lastly, we're going to be doing explicit formula. So the explicit formula is the same, as when we did finding the nth term. So the formula for this one is A to the N equals A1 times Rn minus 1. Or if you just want to think about this multiplying like that, that's fine too. So remember, we're just writing general equations, so nothing too scary here. We want to start by finding our common ratio. So 8 divided by 16 is going to give me a half. 4 divided by 8 is also going to give me a half, so that checks out. So my common ratio is 1/2. So I do just want to write the formula. So I don't know what term I'm solving for, so it's just going to be AN equals my first term, so 16, times my ratio, so 1/2, to the N minus 1. Same thing here. If I have 1, negative 2, 4, so on and so forth, I'm going to find my ratio. So to go from 1 to negative 2, I'm multiplying by negative 2. To go from negative 2 to 4, I'm multiplying by negative 2. So my ratio is negative 2. I'm writing that formula. So AN is going to be my first term times my ratio to the N minus 1 power. So these would be your answers in Delta Math for writing those formulas. So that was the long and the short of it of geometric sequences. So I know we covered a lot in this video. We covered identifying, finding the term, recursive and explicit formulas, and writing their equations. So please, if you are struggling, please come into the Google Meet and ask me questions. I know that was a lot, but I know you all don't want to sit through multiple videos. So we'll see how this goes. Not sure if I like this format or not, but we'll play it by ear. As always, please ask questions. Please reach out. Please make sure you're staying on top of your assignments. We do have to finish this unit before we go to break. So hope you all have a great day if I don't talk to you again. So I will see you all tomorrow. See ya. Bye.